Okay, so now we're going to follow up Monday's notes where we just drew angles with angle relationships. All right, some of the phrases are going to be familiar. We're just going to do it a little different way. So complementary angles, two angles whose sum equals pi over 2. So rather than 90 degrees, we're going to talk about it in terms of radians. Given an angle, find its complement by subtracting its value from pi over 2. Convert by making the numerator 1/2 the denominator, along with the pi. If the angle is greater than pi over 2, then there is no complement. Supplementary angles are two angles whose sum equals pi. Given an angle, find its supplement by subtracting its value from pi. Convert by making the numerator equal to the denominator, and if it's greater than pi, there is no supplement. Okay, so this is what I mean by subtracting. All right, so theta equals pi over 3. All right, so to find its complement, we do pi over 2 minus pi over 3. Okay? Well, if we make this 1.5, because that's what it's pi over 2, or we find the common denominator, either way we would get 3 pi over 6 minus 2 pi over 6, which is just pi over 6. When we do the supplement, okay, this is what we mean by adjusting numerators and denominators. The original angle is pi over 3. So I'm just going to do 3 pi over 3 minus pi over 3. 3 pi minus 1 pi is 2 pi, so I end up with 2 pi over 3 for its supplement. All right, if you want to do it just by looking at your fraction, put the numerator there, and we got 1. And then 3 minus 1 will give you the 2. All right, so 2 pi over 7. So pi over 2 minus 2 pi over 7. This would be 7 pi over 14 minus 4 pi over 14. 7 minus 4 is 3, so I end up with 3 pi over 14. All right, if I look at my denominator, which is 7, if I look at my numerator, 2, 7 minus 2 is 5. That makes our supplement 5 pi over 7. Theta equals 5 pi over 6. The complement does not exist because 5 pi over 6 is bigger than pi over 2. If we subtract it, we'd end up with a negative. Then 6 minus 5 is 1, so our supplement is pi over 6. All right, so the second type of angle relationship is coterminals angles. Angles with the same initial and terminal sides. To find them, we can either add or subtract 2 pi from the measure given, depending upon what they ask for. All right? When restricted to the interval 0 to pi, just to make sure we understand interval notation, the bracket means it can be equal to 0, the parentheses means it cannot be equal to 2 pi. When asked to find one positive and one negative, continue this process until your angle falls in this range. All right. So, examples. Pi over 4, we want to have a positive. If we're going to add 2 pi, we're going to double the denominator. What's double 4? 8. So we're going to add 8 pi over 4. 1 pi plus 8 pi is 9 pi over 4. So we end up with 9 pi over 4. All right, to get the negative, we just go the other direction. So we subtract. 1 minus 8 is negative 7. So I end up with negative 7 pi over 4. All right, next one. Theta equals 5 pi over 6. Double the denominator, 12. So if I add 12 pi over 6, 5 plus 12 is 17. I got 17 pi over 6. Same thing by subtracting, minus 12 pi over 6. 5 minus 12 is negative 7, so I end up with negative 7 pi over 6. Boom, that's all it is. All right, find the coterminal angle in the interval 0, 2 pi. Okay, so first off we see, is it too big or too small? In this case, it is too big, so we're going to subtract. Minus 2 pi, we get 3 pi. We realize it's still too big. So we repeat the process, so minus 2 pi until we get pi. If you see that you're going to have to double it, feel free to use that method. So now I got pi. Is the coterminal angle. It means they're both going to end up in the same spot. 17 pi over 3. All right, if I double 3, I get 6, so minus 6 pi over 3. 17 minus 6 is 11, so I got 11 pi over 3. Still too big, so I do it again, minus 6 pi over 3. 11 minus 6 is 5, so now I got 5 pi over 3. All right, so my final answer is 5 pi over 3. Negative 22 pi over 7. Now it's too small, so I'm going to double the 7 and get 14. I end up with negative 8 pi over 7. Still too small, so I add 14 pi over 7. 14 minus 8 is 6, so 6 pi over 7. All right, third and final thing is conversions. We did this a little bit the other day when we drew or sketched, so we have to think of 180 and as 180 degrees. All right, when we convert radians to degrees, we're going to multiply the non-pi portion by 180, so you just drop the pi. All right, converting from degrees to radians. All right, we divide by 180 and reduce. So whatever we get, we reduce the fraction. Then you attach pi to your final reduced answer. All right, so if I look at the first batch, I'm going from degrees to 1/8. So I go 135 divided by 180. All right, and that simplifies down to 3/4. So now I got 3/4 pi. All right, 540 divided by 180 equals 3. So now I got 3 pi. Last one, negative 220. So negative 220 over 180. Don't forget the negative. Zeros cancel out. 22 and 18 are both even. So I got 11 ninths. So I got 11 ninths pi. Boom shakalaka. All right. Converting each to degrees. 9 pi over 2. All right. All I'm going to do is get rid of the pi and multiply by 180. I end up with 810. 180 divided by 2 is 90. 90 times 9 is 180. All right, I'm a big fan of dividing first. It just makes my numbers smaller. 180 divided by 6 is 30. 30 times 5 is 150, so that's 150 degrees. And then negative 8 pi over 3 times 180. 180 divided by 3 is 60. I end up with negative 480 degrees. All right, so we're going to go back to the book and give you a book assignment based upon that. And then from there, all right, then tomorrow, whether you're in class or whether you're at home, we'll talk about the third and final part of this unit, which is arc length, linear speed, and angular speed. Stay safe, everybody.